Now here we study the different possible cases of the LPP based on the type of the solution. So let us see the different situations. First is what is called as the unique optimal solution. So what it means is, let us consider some sample feasible region. Okay, so these are the constraint lines, and let us consider that this is the feasible region that is coming out based on the constraints. Now we have seen in corner point method as well as the ISO profit or ISO cost line method that we can get a unique or a single vertex which gives us the optimum value of the objective function. Okay, so that is called as the unique optimal solution. There is only one solution. There is another possibility that there are infinitely many optimal solutions. Now let's see in which situations this may happen. So once again, let us consider the feasible region as we have seen in the solved example earlier. So this is the feasible region of some LPP which is of maximization type problem. Now if you recollect, in case of corner point method we have to evaluate the value of the objective function at all the corner points, correct? And whichever corner point gives us the maximum value of z, that is the optimal solution. Now it may happen that not one but two corner points give us the same maximum value of the objective function. So what it means is, all the points that lie on that particular edge joining those two vertices represent the optimal solution. So clearly, since there are infinitely many points lying on any edge, this represents the second case of infinitely many optimal solutions. Right? So all of these points will give us the same maximum value of the objective function. Right? Similar situation can occur in case of minimization problem also. There might be two vertices which give us the same minimum value of objective function. Let's see another case which is called as unbounded solution. Now let's see what this is. Now sometimes we may have the feasible region of a slightly different nature as shown here. Here I am shading the feasible region. As you can see that this feasible region, it is unbounded because there is no end to it on this right side. It is going on indefinitely. And suppose that this particular problem is of maximization type. So in that, if you see, you can take any point which is as far as possible and you will keep on getting the value of the objective function more and more, because as you consider a point which is farther and farther, obviously its x and y coordinates will go on increasing, and hence they will give us the bigger value of z, and there is no end, there is no upper limit to that. So therefore that is called as an unbounded solution. Right? There is no point where you can stop and say that this is the value of the this is the maximum value of objective function. Right? There are endless points, and therefore that is called as unbounded solution. And lastly, there is a fourth case called as infeasibility, that is no solution. As the name suggests, there is no feasible region at all in the first place, and you may wonder in what case it may happen. So let's consider this. Suppose this is one constraint and the arrows are on this side, and there is another constraint like this and the arrows are on this side. Okay. Then you have of course non-negativity constraints. So that is the region above x-axis and the region towards right side of the y-axis. Now if you observe closely, there is no region which is common to all of these individual constraints. Right? Because if you see, the region to the left side of this particular constraint and region on this particular side of the second constraint are not having anything in common. So therefore we cannot find any feasible region of the LPP. Hence this is the situation called as infeasibility. And since there is no feasible region itself, there is no solution also to the given LPP.